In this lecture, we're going to continue with IP addresses and ports, and the pair of an IP address and a port is called a socket. So if we are using a UDP connection that is connectionless, then we use one socket, IP and port. If we use a TCP connection, then we use a pair of sockets. It is really two individual sockets making up the pair. Since we need that bidirectional communication, we have an IP and a port, both for the source and the destination. If you look at the image over here on the right, this is my data from browsing IC Square's website. You can see my source pair is 192.168.06:49691. Before the colon is the IP address, behind it is the port. You then know that is an ephemeral port, which makes sense because this is a web session. If you know a little bit about networking, you can see that my address is a private address and the address I connect to is a public address. If you look all the way out to the right, you can see it is a TCP session, which it should be because it is a website. If you look at the third column, you can see an IP address, then colon HTTPS. 195.122.177.218 is ISC Squared's website. After the colon, where you would normally see a port number, you see HTTPS. And it is very common to translate well-known ports to what they actually do. It is a secure website, meaning it is port 443 that is then translated into HTTPS. So an IP and the port is the socket. For UDP, we need one. For TCP, we need two. And that is a socket pair. Now, let's look at how IP addresses are allocated, and I don't mean the individual IP, I mean by region. So the allocation to each region is governed by IANA, Internet Assigned Numbers Authority, which then in turn is a department of ICANN, Internet Corporation for Assigned Name and Numbers. And don't worry, there will be plenty more abbreviations in this section. Now, do you need this for the exam? Maybe. I mean, it's part of the curriculum. It's something that you just need to remember, which is an easy win. So I would learn it. So back to IANA. They have divided the world into 5 major areas, and each of those areas have an organization that handles the assignment of IPs for that area. If you are in Africa, then it is AFRINIC. ARIN handles the United States, Canada, and some parts of the Caribbean and Antarctica. APNIC handles Asia, Australia, and New Zealand, and many of the Pacific Islands. Then LACNIC is Latin America, Mexico, and part of the Caribbean. And then finally, RIPE NCC handles Europe, Russia, the Middle East, and Central Asia. When IPv4 was more prevalent, these organizations were far more active because they assigned all the IP addresses for their area. But as you know by now, there are so many IPv6 addresses, it doesn't have to be handled as carefully. So if you want a static public IP, then you contact your internet provider, they assign you a public IP, you give them some money, and that IP comes from a pool of IPs that they are assigned. I worked for an ISP in Denmark in the IP backbone 10-12 years ago, and I remember a lot of late nights where we tried to squeeze a few extra IPs out of something. We had long project meetings about maybe we can do this network design and then we can save this many IPs. And at some point we got, I don't remember, 100,000 extra IPs. At that point, that would have lasted us years. So all of a sudden, all those wonderful projects were canceled. And I think that huge influx of IPs we got all of a sudden was when they took a bunch of IPs from AFRINIC because they didn't use them. They then distributed those millions of IPs out to all the other regional internet registries. As mentioned before, this is less of an issue now because we're using IPv6 so heavily, and we have to. But regardless of that, just know these simple facts. Now let's finish out this lecture by looking at the different types of traffic that we can send, and then in the next lecture, we will cover IPv4 and IPv6. First off, we have unicast, and that is one-to-one traffic. That is me sending traffic to a host and the traffic returning from that host to me. If, as part of our network forensics or our monitoring, we want to capture all unicast traffic on our network, We can attach a device to our switch, which has a networking card in promiscuous mode, meaning receiving all traffic, and then on the port on the switch, we configure that port to be a span port, and that could be part of our intrusion detection or our intrusion prevention systems to keep an eye on all the traffic on our network to ensure nothing is malicious. We can also use multicast, and that is one to many, but the many is a predefined list. You can think of this like a TV subscription. We send our signal out to everybody who pays for that specific package. Everybody else, they don't get it. And then we might have a lower bundle that everybody gets. You can think of that as broadcast. That is one to everybody. And that is sent to everybody on our local network. If it is a limited layer 3 broadcast, remember layer 3 has IP addresses, then we would use the IP address 255.255.255.255 as the broadcast address, but also remember here that routers do not pass limited layer 3 broadcasts. So whenever that traffic hits a router, it gets dropped. A limited layer 2 broadcast uses MAC addresses because, well, they're layer 2. So if you want to broadcast something on layer 2, you would use FF:FF:FF and so on as the broadcast MAC address, and that would then send it to all the nodes on that local segment. Today, it is very common for networks to be logically connected, and to be that, they have to be on the same IP range, but they can still be separated by routers. So for that instance, we use directed broadcast. Let's say our accounting department is located in 3 separate remote buildings. As long as they are on the same local segment, it doesn't matter that they're not physically connected. All it cares about is the logical segmentation. If the accounting department has the private address of 192.168.19.12/24, then a direct broadcast will be presented to all the hosts on that network. And with that, we are done with this lecture. I will see you in the next one where we start on IPv4.